My name is Jeff Schweitzer. I am a marine scientist with a PhD from Scripps Institution of Oceanography, and I have been asked to give a brief explanation of the Coriolis effect. First, I want to dispel some myths. This effect can only be seen over vast distances. No matter what you might hear, you cannot see water spinning in a sink or toilet in one direction in the northern hemisphere and in the other direction in the southern hemisphere. Over small distances, the Coriolis effect is so extremely tiny that it is simply not detectable. So, what is the Coriolis effect? Take a globe like the Earth, and for a moment, let's stop it from spinning. Now, let's take a journey from the equator to the North Pole. Let's go in a straight line. And in fact, the path that we take will be a straight line. Now let's take the Earth and spin it and take that same journey. As a sphere, the Earth is bigger at the equator, obviously, than at the poles, so it gets smaller as you move north. The diameter of the sphere decreases toward the poles. Clearly, it's a sphere. Therefore, as the Earth rotates, an object at the equator is traveling west to east faster than anywhere on Earth because it has the farthest to go. As that object moves north from the equator, it spins to the east at the same speed that it had at the equator. The object conserves its original rotational speed as it moves north. That point is the most important thing to understand here with the Coriolis effect. So let's repeat it. Any object conserves, that is, retains, its rotational speed as it moves north away from the equator. That is the essential point. That's what causes the Coriolis effect. Because the Earth gets smaller as you go north, but you have the same rotational speed you had starting out at the equator. So you will now go a greater distance to the east because you're going the same speed over a smaller distance, a smaller radius. The result of that is a curved path to the right in the northern hemisphere, and of course the opposite in the southern hemisphere. That is the Coriolis effect. It's simply a consequence of the conservation of rotational speed as you go from the fat part of the sphere to the narrower part of the sphere. That's it. That is the Coriolis effect, and that is why you have a curved path to the right in the north and a curved path to the left in the south. I hope this has been helpful.